So when you type in your equations to graph, first of all, they give you a window. So your window looks like it's on the x's, -4 to 4, -6 to 6, something like that. And then on the y's, -20 to 20 or something like that.
That is not
You gotta put the X plus 1 times.
When you type them in, be careful.
I see. I just saw that.
Remember, if there's more than one thing in the denominator, it needs to be in parentheses, unless your calculator automatically puts them all in the denominator, which some of the newer ones do. So I'm gonna just call the graphs 1, 2, 3, 4, 5, 6, right down in order. Tell me when you've graphed it. 4 is B.
2's F.
That's what I got. What?
2's F.
2 is F. That's what I got.
I think
1 is C.
1 is C. That's what I got. Yep. Okay. What's 3?
Oh,
Did you make
I didn't.
Oh, I didn't want
no, put in the parentheses and
Well,
then
You got which one?
you have to go like 20 to -20, but the thing that like the graph shape changes when you put the denominator in parentheses.
Oh, maybe I just like cracked it off. Yeah, I just
No, you just put the denominator.
What? Okay, guys, can't wait here forever. Tell me what the other ones are. 3 is D. And then what's 4?
A.
Thank you.
Yeah.
It's not even your thing to
Oh,
do,
it's
but thank you. I'm not sure what's going on over there, but they can't get this graph. And that leaves this last one is E. So I want you to look at the equations and look at the curves that you got. Now, it's hard to tell. Well, it's really not hard to tell, but you recognize there are asymptotes in this picture, right? In these pictures, they all have asymptotes. And you can certainly tell where the vertical asymptotes are for each picture because of the denominators of the fractions, right? Yeah. Now, what about the horizontal asymptotes? Well, take a look at problems A and E, graphs A and E. What can you tell me about the horizontal asymptotes for A and E versus the, I'm using quotations, horizontal asymptotes of the others? Do you notice anything? A and E actually have horizontal asymptotes. All the rest of them have slant asymptotes. Look at question B, or graph B, graph B. Look as it goes to the left. Can you see how it's kind of going down?
Yeah.
It's not going horizontally. Now in problem A, they're going horizontally. In F, they're kind of slanting. In B, they're slanting. In F, they're slanting. What's the difference? Why do A and E have actual horizontal asymptotes, but the other ones don't? This is equation 5, and it graphs with as A, and then I'll just do equation 1. Equation 1, and it graphs as C. Okay, yeah, Cindy?
A and E don't have X standing alone, it's only in the denominator.
Exactly. So what difference does that make? Well, kids, I want you to look at this equation. As you go off the page, as X gets bigger and bigger and bigger, either direction, what happens happens to these fractions? As x gets bigger and bigger and bigger, don't they get smaller and smaller and smaller? So we end up adding 2 plus smaller and smaller things, which means the farther we go, the closer to 2 we get, because we're adding and subtracting small things, smaller and smaller and smaller things. So this horizontal asymptote is y equals 2. All right, well, what happens here? Well, as x gets bigger and bigger and bigger, aren't these still getting smaller and smaller and smaller? Yes, Mrs. Ford, they are. This fraction's gonna get real small, this fraction's gonna get real small. So we kind of can disregard them because they get so small. What am I left with? Not just 2, I'm left with a line, x plus 3. That's the asymptote of picture C. Y equals x plus 3 is going to be the asymptote of that picture out of the ends as x gets bigger and bigger and bigger. Okay,
That's what the slant asymptote.
well, it is going to be a slant asymptote. Now, it's not, it's, remember, there's a lot going on in graph C. There's a lot going on. But as graph C goes off the page, so if you think about what the line x plus 3 looks like, can you see the curve approaching that as it heads off the page to the right? And as it heads off the page to the left, it's coming down along that line too. Now, in the middle, there's all kinds of, stuff going on. Yeah. Okay, so those are the observations I kind of wanted you to make. So, any other observations we can? Some of the pictures have a parabola-like thing. It's not a parabola, but you know what I mean, kind of a parabola-like thing in between. And some of them have like a tangent, squiggly in between. Is there anything you notice about those equations? A has a parabola, so I'm going to put stars by this. So that equation has a parabola. Equation C has a parabola, and again, it's not really a parabola, I'm just using that word loosely. And equation F has a parabola. All right, do you notice anything about those equations versus the ones I didn't start, the ones that have squiggly lines?
The numerators are the same. Like it has 2 and 2, 1 and 1, 2 and 2, and that's
I didn't notice that, Sammy. I didn't notice that. I don't know if, I mean, yes, that's an observation, 100%. What I noticed was something else. I'll have to check and see if that matters. Have you noticed anything else about them, Catherine?
They have opposite signs.
Yeah, the 2 things that I'm adding, the 2 little fractions on the end here, one of them's positive and one of them's negative. It looks like if one is positive and one is negative, then I get a parabola type shape. But what happens if they're both negative or both positive? Then I get a tangent-like shape, a squiggly line-like shape. So Sammy, I'm gonna have to, when I have some time, I'm gonna like change a couple numbers and see if it changes the shape. I don't think it's going to, I think it's sign related, but that is a good observation I did not see at all. Okay, all right, one more partial fraction, a couple of graphs, and then something really super cool, and then hopefully we can do some homework stuff. Alright, so let's take a look, one more partial fraction. Can anybody remember from yesterday? I think it was yesterday. How do we do this problem? What do I have to do first? Factor my denominator. Oh, it's already factored. Life is good, it's already factored. Alright, so now I'm gonna set up my partial fractions. What are they gonna look like? A over x, b over x squared, and c over x plus 2. Now, kids, the order you do those doesn't matter, so don't get all hung up on that. You're gonna have a fraction with an x, a fraction with an x squared, and a fraction with an x plus 2. Okay? Remember, when you have a repeat factor, we talked about this yesterday, when we have a repeat factor, a squared factor, you have to include a fraction with it by itself and a fraction with it squared. If it had been a cubed factor, then you would have a fraction with itself, with the squared, and with the cubed. Okay? Those are the rules of the game. Alright, now what do we do?
Multiply everything by the other.
Multiply everything by x squared and x plus 2. Now, I like to write it down. You don't have to. You can do this in your head, for sure. But I like to write it down. And the reason that we are multiplying through by the common denominator is in order to clear the fractions, right? We're gonna clear them out. So this is going. So we have 4x plus 4 equal to, okay, what are we gonna have here? Well, that's gonna cancel with that. So I'm gonna have ax squared plus 2ax. That's gonna cancel, so I have bx plus 2b. And that's gonna cancel, so I have cx squared. Does that look about right to everybody? Now, because these are equal, the variables on each side have to match up. So, I have x squareds over here. I don't have any over here. So that equation is going to look like 0 equals a plus c. Does that make sense to you? Because you got ax squared and cx squared, and they have to add up to 0. All right, what about the x's? 4 will equal all the x's over here, which is 2a plus b. Is that right? Did I get them all? And then that 4 has to equal 2b, which means b is 2. And if b is 2, then it looks like a is going to have to be, put a 2 in there, so it's going to have to be 1. And if a is 1, then it looks like c is going to have to be -1. This is a system of 3 equations, 3 unknowns. We have methods of solving that, like RREF. If we need to, we could do that. This one was easy enough, there was no need to go through all that work. Write your answer. Your answer is the fractions. So 1 over x plus 2 over x squared minus 1 over x plus 2. If you add up those fractions, you will end up with this. Okay? Yep.
How do you know that the last one you're subtracting?
Because it's a negative. I mean, it's,
That just go, okay.
all right. Let's do 2 quick sketches. This is review for us, and then we're gonna do some cool stuff. All right, so think back, all the way back to chapter 2, a long time ago. We sketched these things. We're sketching them again. How do we start? Factor. Yep, we want to factor everything. So we have x minus 2, x plus 2, over x plus 3, x minus 2. Uh-oh, what do you notice? There's going to be a hole in the picture. Anybody remember, impress me, anybody remember what's the real name for a hole?
Oh,
Jump.
removable discontinuity.
Removable discontinuity, that's exactly right. And why is it removable? Because we cancel it out. Why is it a discontinuity? Because it breaks the picture. It's like an asymptote, not quite as hard as an asymptote, which is a non-removable discontinuity, but it breaks the picture. So, we're gonna have a hole in our picture at the point where x is 2, because that is the factor that got canceled out. 2 would make this 0. So your hole is there. How do you get the y? You plug 2 in right here, so if I plug 2 in right here, y gets 4/5. So in my picture, I'm going to have a hole at 2, 4/5. So I'm gonna label it, put a little open circle there, label it, there it is, there's my hole. Now, we also need the intercepts and the asymptotes. By the way, will every picture have a hole? No, you only have them if this happens, and that doesn't have to happen in every problem. All right, what about asymptotes? What can you tell me about those? Now, if I plug in 0, I get 2/3. That isn't an asymptote, what's that? That is something, but what is it? That's my y-intercept. So my y-intercept is 0 2/3. I get a y-intercept by plugging in 0. 0, comma. All right? Well, tell me something else out here.
Wouldn't your vertical asymptote be -3?
X equals -3, that's exactly right. My vertical asymptote, which is a non-removable discontinuity, it does not remove from the problem, it stays there. That's my vertical asymptote, and that is where the denominator is 0. My problem is undefined there. Okay, what else?
Solve for the x-intercept.
Okay, to solve for the x-intercept, I need this thing
Y
to equal 0. And the only way that fraction's gonna equal 0 is if x is -2. That is exactly your x-intercept. X-intercepts are whatever you can plug in to get 0. Y has to equal 0. So she said, I looked right there at my numerator and said x has to be -2. All right, well, how about my horizontal asymptote? That's the last thing, and we actually talked about it a little while ago.
1.
It's at 1. Y is my horizontal asymptote at y equals 1. What?
It's x squared over x squared.
It is. The original is x squared over x squared, and this one is x over x. So remember, horizontal asymptotes are limits as x gets big. We were talking about them a little bit ago. as x gets big, and I'm talking about infinity big, billions and trillions big, do the 2 and the 3 have any significance? If this is a billion, that 2 isn't very much, right? And the 3 isn't very much. So basically, if x is a billion, you got a billion over a billion, which is 1. That's why we look right here. Okay? Now, at this point, everything that I listed there, you have in your picture. So now you gotta generate the picture. Would you remember what these things look like? You remember? Well, you got 3 points right here, so this part should be easy for you.
Same thing across the origin. Well, not the origin.
The, like, translate the origin over here. So Peter says, then I'm gonna have a piece of it over here like this. Now, 2 things about that I want you just to have in the back of your mind. First of all, when you approach a vertical asymptote, you're either gonna go up or down because you can't cross it, right? So the curve has to either go up or go down. You have no choice. Secondly, as you head off the page, you have to be getting closer to your horizontal asymptote because that's the limit. We said that's what happens when x is really big or really small. So if you think about it, there isn't any shape other than either that or that could happen over here. Would you agree with me? Well, why can't it be this one? It can't be this one because what would the curve have to do? Have another x-intercept, and it doesn't have another x-intercept. So it cannot cross the x-axis, which means it must be this piece. Now, I don't know if it's the end of the day, I don't know if I'm totally confusing you, I don't know what all these blank looks mean, but if you're confused, what else could you do to guarantee yourself that it's this part up here?
Plug a point.
Plot points and points, yeah, plots and points. Always, when you're confused, if you can't figure out what's happening, plots and points. Right? All right, let's do the last one, and then we'll do our fun stuff. Okay, so we're gonna do the same thing. Uh-oh. I don't think the numerator factors, do you? No, it doesn't. The denominator does, but that's it. Which means, what about holes in this problem? That's fine, because we're gonna have any, all right. What do we have?
Vertical asymptote with 5 and -1.
So we have 2 vertical asymptotes. One of them is at 5, x equals 5. Make sure you're using a letter. Verticals cross the x-axis. So x equals 5, x equals -1. All right, perfect. What else? Liam?
Is there a horizontal asymptote that's y equals 1?
There absolutely is a horizontal asymptote at y equals 1. Remember, the word asymptote has a p in it, but we don't say it. It's asymptote, and it's at y equals 1. Because we've got x squared over x squared. Perfect. All right, tell me about intercepts. Do I have a y-intercept? -1/5. How did she get -1/5 for the y-intercept? She plugged in 0, which is how you find y-intercepts for everything. Doesn't matter what it is. Any equation, you're gonna plug in 0, and that's how you find your y-intercept. How about x-intercepts?
No.
We don't have any, because if you set this fraction, think about this for a second. If you set this fraction equal to 0, that's what an x-intercept would require, you to equal 0 for y. If you multiplied this over here, you know, like regular solving, wouldn't you be left with this? And if you tried to solve that, what's going to happen? You're gonna get imaginary. So there are no real numbers that will make that fraction equal to 0, which means there are no x-intercepts, which means it's not gonna cross the x-axis anywhere. So what's it look like? If we know it doesn't cross the x-axis, what's going on in here?
It goes up on the
It's
left.
gotta come up like this, doesn't it? And then do something and come back down. Now that does not have to be a parabola, so please do not assume it is. We're doing a rough sketch, so it has a parabolic like behavior. Would you agree with that?
The same thing on
And then what else do we have?
the one.
So over here, doesn't it have to look like this? Why does it have to look like that? Because it can't cross the x-axis, so it can't be down here.
It can't be right above it.
It can't cross the Y either.
Wait,
Oh.
wait,
Well, wait a second. Wait a second. When we say it can't be right above it, remember, these are functions.
line test.
And so they have to pass the vertical line test, so I would never do something up here. Because I already have a piece down there, right?
I'll get that part of
It's just kind of random, not like, for the, horizontal asymptotes, it's based on like, if you had x cubed over x squared, would that be?
That would be a slant asymptote, that's not gonna be horizontal.
And what would that slant asymptote be?
Well, if that's all you had, it'd be y equals x.
Okay, so then the like horizontal asymptotes, it'd be like 2x over x.
Yeah, that would be y equals 2. Okay, all right, now the moment we've been waiting for, we're gonna wrap up. We're gonna wrap up 7-4 today. So we got a triangle out here. And I am not gonna plot these points, it takes too long and it's not important anyway. So I've got 3 random points. You can put them on a graph, a grid, if you wish, it won't matter, it doesn't impact the problem. And we're going to find the area of this triangle in a couple of different ways. Okay? Now, the first part says, find the area using the dot product. Okay, now if I'm gonna do a dot product, I need vectors. So I'm going to start by building a couple of vectors. And I'm a creature of habit, so I am gonna build vector CS and CH. If you would rather build SH and SC, you're welcome to do that, it doesn't matter. But when we're doing the dot product, the vectors we build have to be emanating from the same angle, or the same vertex. So I said CH and CS. Does that make sense to you? All right, so here's how this works. What are the coordinates of vector CH? From C to H. You know this. What is it? No. From C to H is 4, -1. Vector number 1. From C to S is 3, -9. Everybody okay with that? Now, I know, it tells me to use the dot product. I know that the dot product of these two vectors can be calculated by taking x times x, y times y, and adding them up. Remember that? So this would be 12 plus 9, which is 21. Agreed? I know also that the dot product can be calculated by taking the magnitude of the first vector. So what's the magnitude of this vector? Root 17 times the magnitude of the second vector, which is root 90, and you don't need to simplify that, just leave it root 90, times the cosine of the angle between the vectors, which would be C, this time, angle C, right? And since these are both the dot product, I can set them equal to each other. I'm gonna make that a little simpler. What's 17 times 90? 1530. Cosine C. So the cosine of angle C is 21 over root 1530. Now, you did that on a test or quiz or something. Does that look vaguely familiar to you? To find the angle between two vectors, we can use the dot product. Now, that wasn't my job. My job was to find the area. But once I know the area, excuse me, the angle, I can find the area by doing 1/2 side, side, sine. Remember that? So here we go. I'm gonna write that down. So my area is gonna be 1/2 times root 17 times root 90 times the sine of angle C. Now I'm going to do this totally on my calculator. So I'm going to second cosine 21 divided by the square root of 1530. And I got 57.5 something. Is that what you got? Please work with me. Now that is angle C. In my area formula, I need to know the sine, so I'm just gonna do sine answer. And then I'm gonna take that times the square root of 90 times the square root of 17, I could have combined those, I guess, and divide that by 2. Did you get for your area 16.5?
She did sine, answer.
Did you have to divide out the cosine?
Huh?
How'd you get rid of the cosine?
I second cosine this number, and that gave me the angle.
That gave you C.
Yeah.
Okay.
Then I signed it,
Right.
and multiplied it by the rest of that stuff.
Yeah, the second cosine.
Yeah, I got
That's, okay,
Now, you're all sitting down, and this is good news, because I am going to knock your socks off, okay? Here is what I want you to do. I want you to take these two vectors that we built, and I want you to just set them up, don't change anything, just copy and paste them into a little determinant. Okay? So we just copy and paste into a little determinant. Do exactly the way they are.
I only did 2 vectors instead of the 3.
I don't have 3 vectors. What are you talking about? I have 2 vectors. I have CH and CS. Okay. Now I want you to evaluate that determinant. So negative 36 minus negative 3 gives me negative 33. I want you to divide that by 2, because anytime I'm doing area, it's half. half base times height, half side, side, semi-perimeter, it's always half. What's 33 divided by 2? Whoa, 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 there is your area. So you do not ever need to do all this crap again. If you want the area, you build 2 vectors in the triangle and evaluate the determinant.
And it's always positive?
Divide it by 2 and make it positive, yeah. And the reason I make it positive, kids, is if I had, look, if when I built my original vectors, if I had built this one first, if they were in this order, do you see how that would turn out to be positive anyway? So if your determinant value is negative, just make it positive. And that is going to be your area. Well, that's how you do it, but it makes sense because when you do the area of a triangle, it's always half. Every triangle area formula has a half.
There's one more chapter left.
Right?
That's
If you don't divide by 2, wait, stop. If you don't divide by 2, what you would have is the area of the parallelogram created by those points. By a parallelogram created by those points. Okay? All right. So now what I want to do is hand back a few things, including your quizzy poos. And some homeworks. So someone can help me so we get this goes quicker. You know everybody in this class can know that. All right, so here comes
Sure, you have one here.
Our quizzes were inflated by a massive birthday bonus. So you need to look, even though your grade might be good, you need to look to see if you missed something. And you need to figure out why you missed it.
Wait, what is I think not what you grade. Hey, who got
Oh, it's one minus 2, it's -1. So you mean? I'm such a goofy little one. This is why I got it 20. I think it's out of 20. I'm pretty sure. And then this one, remember when I asked you how you like this answer? I just listed the numbers, I didn't add it up. I didn't know how to get it. No, you're supposed to like add it up.
So,
I just listed it. I didn't know how to do that.
so who is something and has a question about it?
I have one on number 10, on letter 10.
Which letter?
10.
Number 10?
Inverse of the
I have a number 10.
Oh, no, you can't.
K.
K.
Okay, oh,
That's the second.
okay. So the question here is, matrix P is 2, 5, -1, 6, and we need B inverse. Okay, thank you. So, what are the steps to finding the inverse? There's 2 things I need to do. What do I need to do to find an inverse? need to find the determinant first. So the determinant here is 12 minus negative 5, so the determinant's 17. Right? Then what? I gotta make a new matrix by flipping these two, making that negative and making that one positive. Then what do I do to put it all together?
Put it over 17.
Put all these over 17. Yep. And that would be the inverse. If there's anything to simplify, I simplify it. Otherwise, I don't. Okay, Mary?
Yeah.
You do on the quiz with 2 marks, number L.
Okay, quiz with 2 hearts, number L, you say?
Yeah, letter L.
Alexis
No. Is this a hot quiz? Is this a quiz? Or is this a formula?
What do you
Two hearts. Number, which one did you say? L. So 2 hearts L. A minus C.
Yeah. I don't know what I did wrong.
2 times A. Minus. So this is gonna be 2, 0, 8, 2, 2, 6, right? Yeah. So 2 minus 2, 0, 0. 0 minus 1. 8 minus negative 1.
I already see what I did wrong. I didn't put it in the box.
All right, now what I've just given you is practice for our next quiz, which will be on Friday. All right, 3 little problems, 2 of which we have talked about today. So I'm going to skip down to number 3, which we talked about, but not today, and do number 3 first. All right, so I'm going to cross elimination. That means by hand. This is no calculator. All right, do it by hand. So 1, 1, 1, negative 2. These are my x, y's, and z's, and my equals. 2, 3, negative 1, 7. And 3, negative 2, 2, negative 13. Everybody with me so far? Problem number 3. Now, I'm doing this by hand. So the first thing I need to do is focus on getting zeros where? Right here. Right here. Right? So I'm gonna go ahead and write down that top row. He's all good. I'm gonna use him the whole time. I mean, he'll give me my final answer in the end. Now I need to take that top row and add it to the second row and make that a 0. So obviously I'm gonna have to multiply my top row by negative 2. So write it down, do it in your head, I don't care. That's gonna give me a negative 2, negative 2, negative 2, and 4. So when I add, my new second row will be 0, 1, negative 3, and 11. Are you in agreement with me? Now I'm going to repeat the process exactly, but I'm going to have to multiply the top row this time by negative 3. So that's going to give me negative 3, negative 3, negative 3, it's 6. So adding gives me 0, -5, -1, and -7. How do I do with that one?
11 times -7.
All right? I need one more 0, and then I'll be just about done. What number is where I need a 0? Right there. Yep. So those top 2 rows are all good. And now I'm gonna add this together right here. I gotta keep my zeros. So I'm gonna add these 2 together and make that a 0. So I'm gonna have to multiply my red row by 5. So my red row by 5 will give me 0, 5, -15, and 55. I'm multiplying 5 times the red row so that becomes a 5, so that I can add it to this guy and get the 0 that I want. So what have I got? 0, 0, -16, and 48. All of my zeros are in place, but there's one more little detail to take care of, and what is it? The bottom row has to be divided by -16, because what does put your name down please, Mary. What does Gaussian elimination mean?
One has
It's gotta
the
be
first
in row echelon form. Okay, so now I'm gonna solve this. Starting at the bottom, what does that bottom tell me? Z, Z equals -3. Remember, this is the equals right here. Now, what does this row say? Y minus 3Z is 11. So Y plus 9 equals 11, which means Y equals 2. And then the top row hasn't changed from the beginning of the problem. It says X plus Y plus Z is -2. So X plus 2 minus 3 is -2. So it looks like X is -1. So the answer to the problem is -1 to -3. All right, now Mary, what?
Why in the first part, like, to get the third row to have a 0 for the first number, you just keep multiplying by the top row?
Yep. In the first column, you use the first row. When you move to the second column, you use the second row. All right, number 2. We've already done one of these, but it's so easy. You got this. Triangle PQR, we want the area.
Oh,
So what do we need to do? We need to build
vectors.
2 vectors. Doesn't matter which ones, okay? But let's just keep it simple. Let's do PQ and PR. That seems simple enough, right? Come out from the P. All right, so what are the coordinates of PQ? You gotta get this right. PQ is 2, 5. What are the coordinates of PR? 3, -1. And that's all you gotta do now. Make a determinant out of those guys. Don't change a thing, just do this. What is the value of that determinant? -2 minus 15, I got -17. which means the area of the triangle is 8.5. 17 halves or 8.5 is the area of the triangle. All right? Last thing, let's set up our partial fractions. We're not gonna get it done, but let's get it set up. What are your partial fraction setup going to be? Well, aren't you gonna factor your denominator first? Okay, we're not done, guys. Are you paying attention? So what are my partial fractions? A over x plus 3 and b over x minus 2? And then I'm gonna clear my fractions, and so I think I'm gonna end up with this. I don't have time to write it all out, but does that make sense to you? If I multiply by my denominator, I'm just gonna have 5x over here. And then I'm gonna have a times x minus 2 and b times x plus 3. So ax minus 2a and bx plus 3b. Now, don't get confused. I think it's pretty obvious that 5 equals a plus b. But what's negative 2a plus 3b have to equal? 0, because I don't have anything else over here. So that's gonna equal 0. And now what are you gonna do with these guys? Well, substitute or eliminate, whatever you wanna do with that, right? And you'll figure out your A and your B. Right, so Friday, that's what's happening. Well, yeah, I don't have less cards, right?
I hope you had a chance to pray for our team on retreat.